স্যার
বলো
স্যার আপনি যে আগের ক্লাসে যেটা দিয়েছিলেন না ওই
প্রবলেমটা।
কুইজটা
হ্যাঁ, হ্যাঁ,
নেটওয়ার্কিংটা,
হ্যাঁ।
তো স্যার ওর অ্যান্সারটা কি হবে স্যার, এটা একটু
ওর
বললে
অ্যান্সারটা
ভালো
আমি
হতো
তো
স্যার।
অলরেডি পোস্ট করে দিয়েছি তো তোমাদের গুগল ক্লাসরুমে। আমি দুটো অ্যান্সারই পোস্ট
ওকে স্যার,
করেছি।
ওকে স্যার।
লাস্ট ডে মানে যেটা 17th আগস্ট একটা তোমাদের টেস্ট হয়েছিল, সেইটা পোস্ট
হ্যাঁ,
করেছি
হ্যাঁ।
সেই অ্যান্সারটা, প্লাস 31st আগস্ট যেটা হয়েছিল সেটারও পোস্ট করে দিয়েছি।
ওকে স্যার, ওকে স্যার, থ্যাংক ইউ স্যার।
ওকে, if any issue occurs, please ask me after you see the answer, then let me know. Okay, now let us start with time analysis. Here there are two methods. One is forward pass and second is backward pass, and both is required. This is not like it ki we only know forward pass and we will do the analysis. No, that is not going to happen. We have to know both of these methods and we have to apply both of these. So we will elaborate one by one with examples. Let us understand few terminologies. T means estimated completion time of an activity ij. Okay, so T is a time period which is required for an activity to be completed. Es means earliest start. Earliest start time. If we apply suffix I, that means earliest start of I event. If we add es j in suffix, so esi means earliest start time of event I or the tail event. Okay. Now esij means also represents esij. When we call it ij, this means activity ij, earliest start time of activity ij. Okay. So if there is an activity which starts with tail event I or initial event I and completes with j, so this is your activity ij, then the time required is t, maybe small, maybe capital. See, it will be denoted by tij. I will be initial event or tail event, this will be head event. Now earliest start means the much early this can be started. In a whole network, you choose any particular activity and this esij means for this particular activity how much faster this ij can be started. Similarly, ef means earliest finish time. So there are several possibilities that then any activity in a network might end up on different time, but the earliest time, the fastest time of the activity can be completed is called ef or the earliest finish time. Now similarly, ls is the latest start time. Later on we will elaborate on a particular problem. What are the significance of these terms, that we will discuss with a problem. Now latest start time, ls means latest start time. So latest means the last. So when you go for backward pass, then this ls and lf is required. Lf means latest finish time. Sorry. So lfij means similarly the latest finish time. of any particular activity. Now we'll learn the forward pass fast, or to calculate the earliest or earliest start, earliest finish. These times we will know fast. So we'll start with forward pass calculation. So now the forward pass computations yields the earliest start and the earliest finish time, for each activity, and indirectly the earliest occurs time for each event. There are different steps. The first step, the computation begins with start node and move towards the end node. So it is called forward pass. And the starting time is said to be 0. Number 2, the earliest start time, which is written as ESIJ, earliest start time, or it also can be written as EI, is the earliest possible time when an activity can begin, assuming that all the predecessors are also started at their earliest starting time. So if all the activities behind any particular activity is started on the earliest start time, only then that particular activity can be started on start time. So if any project has say 4 number of activities and we are talking about number 3 activity, then number 1 and number 2 activity should be started at earliest start, only then number 3 also can be started earliest. So when you go for earliest start time calculations, we'll assume that all the previous events has been started at the earliest time possible. And earliest finish time, which will be EFIJ, and that will be equal to ESIJ plus TIJ, which is start time plus the activity duration, which we will know properly. If it is not known, then there are different methods we learn when we know about the part. Okay. Now, number 3, earliest event time for event J is the maximum of the earliest finish time of all activities ending that event. So we will call the earliest event time of event J will be equal to the maximum of all EI plus Tij. That means suppose there are 2 or 3 number of activities are merging on a particular event. So that means to reach that particular event, there are 2 3 different types of paths available. And for that, for different paths, different uh, earliest finish time of those activities are available. Now, the earliest start of that margin or the merging event or the next activity will be equal to the maximum of the previous. Now, with a problem, not now, let me complete it fast, complete the topic, then we will go for the example and we will clear all these things. There are backward pass calculation, which is very similar, but sorry, but we start here from the end. So for the ending event in the project, we'll reaching from first to last to forward analysis. Then we start from the last and come back towards first. That is the backward. So both are required. First, we'll go for forward pass calculation. We'll start from start and end to the end of the project. Then we start from the end of the project and come back to first. That is called backward pass. So for ending event, the last event, we assume the earliest finish is the latest finish. Earliest finish is the latest finish. Number two, latest time for each activity ij is the target time for completing the project. So this LF means latest finish. LF ij is equal to LJ, and that will be the target time, and we need to complete the project before this time period. Otherwise, the project will be delayed. We cannot make that happen. Now, number three, the starting time, latest starting time of any activity ij is denoted as LSIJ, and that can be found out by subtracting the time period from the latest finish. So we will get the start by subtracting the time period of the activity from the latest finish. Now, step 4. The latest event time, which say call Li, is to be chosen by taking minimum of the all Lj minus Tijs. So that means if there is any burst event from a particular event, there are 2-3 number of activity has been started. In such case, when he coming back, then there are 2-3 number of or maybe more number of uh, latest start times, and we need to choose the minimum of them. Now these E values of each event to be denoted in a square just above the event, and these L values of backward pass calculation for each event to be kept on a triangle just above the square. Now, there are two more things we need to know. Three things actually. That is called floats and slack. Floats and slacks. Floats are associated with the activity. Float is defined as the difference between the latest and the earliest time activity. Float is defined as the difference between the latest and the earliest activity time. There are three types of floats: total float, free float, independent float. We'll learn them one by one. and the slack is defined as the difference between the latest and earliest event time. So slack is difference between latest and the earliest event time. So slack is used only in case of events, and floats, these are used for activity. There are three different type of floats. Initially, the most important one, total float.
Sir, what is float, sir?
Just wait and watch. Total float refers to the amount of time by which an activity can be delayed beyond earliest expected completion time without affecting the overall project time. So this is basically the amount of time by which the completion of an activity could be delayed beyond earliest completion time. Condition is without affecting the overall project duration, which is basically mathematically denoted as TF, total float of activity ij, that is given by LS ij minus ES ij, or the latest start time of an activity minus the earliest start time of an activity. That is the total float, the amount of time which can be delayed beyond the earliest completion time without affecting the overall project duration. But I mean, each activity can be delayed by some amount of time, but the overall project will not be delayed for that. That is called the total float. And the mathematical form is to be remembered, which is also written as Lj minus EI minus Tij. Now, free float. This is the amount of time by which the completion of an activity can be delayed beyond the earliest finish time. But the condition is without affecting the earliest start of the subsequent succeeding activity. Okay, so mathematically, this free float is written as FF for particular activity ij, and this is written as ej minus ei minus tij, or this is actually total float minus head event slack. We need to remember these points, the mathematical forms. This free float value can be varied from 0 and it may be up to the total float, but it cannot exceed the total float. And this is very useful for rescheduling an activity without any disruption or with minimum disruption in earlier plans. So if we want to delay any particular activity for some reason, then we will know how much we can delay so that the total project duration cannot be affected or the affection will be minimum. That we can find out. Now there is another term which is called independent float. This is the amount of time by which the start of an activity can be delayed without affecting the earliest time of the immediately following activities, assuming that the preceding activity has finished at its latest finish time. The preceding activity finished at latest finish time. After that, we are trying to delay the start of an activity without affecting the earliest start of the next activity. So previous one completed on latest time. We have waited the maximum for the previous case, and we will make sure that the next one will start at the earliest time. So in between, if the project may be varied by some, if the activity may be delayed, the in between activity may be delayed, then it will be called the independent float. And you can remember it as IFij, which is equal to free float minus tail event slack. This independent float may be negative. If it is negative, then it will be taken as 0. Sorry guys. If the independent float is taken as if it is found negative, we take its value as 0. Now we learn the critical activity or critical path. Critical path is the longest path in the network, and the activity is said to be critical if a delay in its start causes the further delay in the completion of the entire project. So critical activity means if it start with a delay, whole project will be delayed. And the critical path is consist of all the critical activities. So the sequence of critical activities in network which determines the duration of project is called critical path. It is the most longest path in the network from start to end and defines the minimum time required to complete the project. Below that particular time, the project cannot be completed. Okay, that is critical path. Now we'll learn all these things with an example, and the problem will be solved by critical path method. So there are few steps. Critical path method steps: list all the jobs and draw an arrow diagram or network, and each job is indicated by an arrow and the direction of arrow showing the sequence of the jobs, and the length of the arrows has no significance. The arrows are placed between the predecessor and the successor and the concurrent relation within the job. Okay, so the length doesn't matter here. This basically is constructing the network. Is the first step. Second, indicate the normal times or the completion times for each activity is to be written above the arrow. These times are deterministic, remember, not probabilistic. We definitely know for a work or for any job how much time to require to do the job. Number 3, calculate the earliest start time and earliest finish time for each event and write earliest time for each event I in a rectangle. So calculate all EIs apostrophe S and write them in a box, rectangular box near or above each event so that we can understand. Number 4, tabulate various parameters according the network. Number 5, determine total floats or others if asked. Total float is required, and if others are required, then you have to find them out. Now, number 6, identify the critical activities and mark with double arrow. And then when this job is done, final part is calculate the total project duration. These are the steps involved. Okay, now we will start solving a problem. So your job sequence with time will be given. It will be such as, let me write them out. Activity, and this is time in days. This is given as 1 2 1 3 2 4 3 4 3 5 4 9 5 6 5 7 6 8 7 8 8 10 and 9 10. Okay, and time taken for this activity is 4 1 1 1 6 5 4 8 1 2 5 7. Okay, so this is given. This is given. Now your job is to construct a network diagram. Number 2, compute all earliest and latest event times. Determine critical path and total project duration. Number 4, compute total float and free float. Okay, this is the problem statement. This is the problem statement. Now if we start this problem, we cannot end it in time. So let us draw the network today, and next day we'll solve the rest. So if we go with the network, we better go to next page. If you look at your problem, then you will find the network will, this is your problem. You look, the activities are named as 1 2 1 3. So from that we can understand there is one start event, that is 1. From that there will be 2 activities, and one activity go to 2, second activity goes to 3. So we will write them as well. Here we will try to finish. So there is activity 1. From here there is 1 2 and 1 3. So there is 2 and there is 3. Okay, now again look at the problem. After that there is 2 4 and nothing came out of 2. So that means from 2 there is only 4, and from 3 there is also 4, and there is 3 5. So from 3 there is 2 things. One goes to 4, another one goes to 5. From 2 it will be like this. From 2 it will go to 4. From 3 it will also go to 4. But from 3 there is another 3 5. So let us draw another arrow and name it 5. Okay, now again come here, there is 4 9. You have to draw 4 9. So let us draw another just 4 9 in such a way. Then it comes 5 6. Can you say it? 5 6 5 7. So that means from 5 there will be 2, one go to 6, another one go to 7. So let me draw it. One go to 6, another one go to 7. One goes to 6, one goes to 7. Now here there is 6 8 7 8. So from 6 and 7 both go to 8. So from 6 and 7 both go to 8. Now again look, from 8 it goes to 10, from 9 it goes to 10. So this is 8, this is 9. So this will reach to 10. Okay, now this is the network we have already drawn. And if you look at the steps here, we have constructed the network. Now second step is write the times above the arrow, and the time is deterministic. So time is given. So for activity 1 2 is given 4. So we will write 4 over here. 1 3 is 1. We will write here. 2 4 is 1. 3 4 is also 1. 3 5 is 6. 4 9 is 5 days. 5 6 consumes 4 days. 5 7 consumes 8 days. 6 8 consumes 1 day. 7 8 consumes 1 day. 8 10 consumes 5 days. And 9 10 consumes 7 days. So this is our step 2. Now
Sir, 7 to 8, 2 days, sir.
7 to 8 2 days. 7 to 8 7 to 8 2 days, right? 7 to 8 2 days. Thank you. 7 to 8 2 days. And if you look, all the numbers, all the number of days are above arrow. Okay, so you have to be careful when you are doing this. Okay, we will stop here today.